Right now, somewhere in China, a machine is pulling fuel out of thin air. Not oil, not gas from the ground. Air and water, that's it. This same country just turned frozen air into a power plant that can light up a city for 10 hours straight. It's making rocket fuel-level chemicals using nothing but sunlight and seawater. And it just broke a record trying to build a tiny star inside a machine, one that could power the whole planet without ever running out. 6 different breakthroughs, all happening at the same time, all connected to one single goal that most people have not even heard about yet. By the end of this video, you'll understand exactly what that goal is and why it could change who holds the power in the world for the next 100 years. If that sounds like something worth knowing, hit like and subscribe so you don't miss what's coming next. Because what you're about to see isn't just one clever invention, it's 6 of them working together, quietly rewriting the rules of who controls energy on this planet. And the last one on this list might be the most unbelievable thing you hear all year. Let's start with the problem nobody talks about. The hidden weak spot. China builds more stuff than almost any country on Earth. Phones, cars, toys, machines, you name it. Its factories run non-stop, and its cities have grown faster than almost anywhere in history. Go into any store anywhere in the world and pick up a random product. There's a very good chance that something inside it, or maybe the whole thing, started life in a Chinese factory. But here's the catch. All of that growth needs energy, and most of that energy comes from oil. More than 70 out of every 100 barrels China uses come from other countries. The Middle East, Africa, Russia. That's already a big number. But the real problem isn't where the oil comes from. It's how it gets there. And understanding this journey is exactly what makes the breakthroughs later in this video feel less like luck and more like a plan years in the making. Every drop of that oil has to travel across the ocean on a ship. And almost all those ships squeeze through one narrow stretch of water between Malaysia and Indonesia called the Strait of Malacca. Think of it like a funnel. At the wide end, you've got the entire Indian Ocean and all the oil tankers coming from the Middle East and Africa. At the narrow end, you've got a gap so tight that ships have to take turns, basically lining up like cars in a single-lane tunnel. At its narrowest point, that strait is less than 3 kilometers wide. Picture a hallway that almost the entire world's oil has to walk through every single day. About 1 out of every 4 barrels of oil traded on the planet passes through that one skinny passage. If something ever blocked that hallway, even for a short time, factories across China could grind to a stop. Prices would jump. The whole economy would feel it almost overnight. Not in a few weeks or a few months. Almost immediately. Store shelves would empty, gas stations would run dry. And the effects wouldn't stay inside China either, because factories all over the world depend on parts and materials that flow through Chinese supply chains. Military experts even have a name for this fear. They call it the Malacca Dilemma. It's not a new worry either. People have been talking about it for decades. China has tried building around it for years. Pipelines through Central Asia, deep-water ports in Pakistan and Myanmar, underground oil storage just in case, massive reserve tanks buried beneath the ground filled with months' worth of emergency supply. But none of that fixes the real issue. The oil still has to cross the ocean first. A pipeline from Pakistan to Western China helps, but the oil still has to reach Pakistan by ship. A reserve tank gives you a few extra months, but eventually it runs empty. This is the exact weak spot that every single breakthrough coming up in this video was built to erase piece by piece. So what if it didn't have to travel at all? What if you could make the fuel exactly where you needed it out of stuff that's already everywhere? That question is exactly what led to the first big breakthrough in this story, and it starts in a place you'd never expect fuel to come from. Fuel made from air. Here's a wild idea. What if a factory could make jet fuel the same way a leaf makes food, using nothing but the air, water, and sunlight around it? That's not science fiction anymore. There's a facility in China doing exactly that. And once you see how it works, it actually makes a lot of sense. This is the first domino in a chain that eventually leads to something much bigger. So pay close attention to how simple the starting ingredients really are. Step 1. A machine pulls carbon dioxide straight out of the sky. Yes, the same gas that comes out of car exhaust pipes, the same gas that scientists have been warning about for decades because it traps heat in the atmosphere. Instead of letting it float around and cause problems, this machine grabs it and gets ready to use it. Think of it like a vacuum cleaner for the sky, sucking up the exact stuff we've been trying to get rid of. Step 2. Solar panels power another machine that splits ordinary water into two parts: oxygen and hydrogen. The oxygen gets let go, released back into the air. The hydrogen is the important part, and you'll want to remember that word because it keeps showing up again and again as this story unfolds. It's the thread that connects almost every breakthrough in this video together. Step 3. You mix that captured carbon dioxide with the hydrogen. Under the right heat and pressure, those tiny particles rearrange themselves into something brand new, a liquid fuel. And here's the crazy part. It's not close to jet fuel. It's not almost the same. It is the exact same fuel down to the last molecule as what comes out of an oil well. A plane engine cannot tell the difference. Pilots couldn't tell the difference. The only way you'd know is if someone told you where it came from. The company behind this is called Carbonology. It opened in January of 2026 in the Lingang district of Shanghai. Right now, the plant is small, making about 100 tons of fuel per year. That's a test amount, enough to prove the concept works in the real world, not just in a laboratory. But the plan is to grow it fast. The next step is a 1,000-ton demonstration plant, then 5,000 tons, then a full commercial facility aiming for 100,000 tons a year by 2027. To put that in perspective, 100,000 tons of jet fuel is enough to power thousands of flights across the Pacific Ocean. Big investors have already put real money behind it. Sequoia China and the Yellow River Delta Investment Fund, names that have seen every clean energy pitch on the planet, decided this one was worth backing. When people who study energy ideas for a living start writing checks, it usually means the numbers actually add up. Airlines already want this stuff too. New rules in Europe require a small slice of airplane fuel to come from clean sources starting now, and that slice grows much bigger by 2050. That means buyers are already lined up before the factories even finish scaling up. The demand was built into law before the supply was even ready. That almost never happens in any industry. Making fuel from air solves one piece of the puzzle, but there's another huge problem hiding behind it, one that has nothing to do with fuel and everything to do with timing. What happens when the sun goes down and you still need power? That's where the next breakthrough comes in, and it might be the strangest one yet. Power frozen solid. Solar and wind power have one big flaw. The sun doesn't shine at night, and the wind doesn't always blow when you need it. So even a city covered in solar panels still has a gap to fill once it gets dark. This gap is one of the biggest reasons the full energy picture we're building toward has taken so long to come together. Most people think batteries fix this, and they help, but even the biggest battery farms in the world usually run out after about 4 or 5 hours. That's fine for a short gap, but not for a whole night, or a cloudy week, or an entire industrial city that needs power around the clock without stopping. Think about it this way. If a hospital loses power at night, you can't just tell the doctors to wait until morning. If a factory shuts down in the middle of a production run, restarting it can cost millions. The gap isn't just inconvenient, it's expensive and sometimes dangerous. So engineers in the Gobi Desert tried something different. They froze air. That's really it. They take normal air, the same stuff you're breathing right now, and cool it way down to about -194 degrees Celsius. At that temperature, air stops being a gas and becomes a liquid. You can pour it into tanks, store it like any other liquid, and it sits there quietly, holding all that potential energy, just waiting. When it's time to use that energy, they let the liquid air warm up again. As it warms, it turns back into gas and expands. Not a little. It expands 750 times its liquid size. That's like taking a small bottle of water and suddenly having enough to fill a backyard swimming pool. That rush of expanding air spins turbines, and those turbines make electricity. This facility sits next to a giant solar farm that produces 250 megawatts of power. During the day, extra solar power that would normally go to waste gets used to freeze more air instead. At night, that frozen air turns back into electricity and keeps the lights on for 10 straight hours. That's more than double what the best battery farms can do, and it doesn't need any of the rare materials that batteries usually require. No lithium, no cobalt, no rare earth minerals that have to be dug out of the ground in one country, shipped to another for processing, and then sent somewhere else to be assembled. Just air, cold temperatures, and industrial equipment that can be built anywhere. The facility produces roughly 180 gigawatt hours of energy per year, and it has been running since late 2025. That's not a test or a prototype anymore. That's a working power plant. This solves the nighttime problem for electricity, one of the toughest walls standing in the way of a fully self-sufficient energy system. But some machines, like ships and factories, can't just run on electricity. They need an actual fuel they can store and burn. And the answer to that comes from a chemical most people only know from cleaning supplies, which is exactly where the story goes next. The cleaning chemical that runs ships. There's a molecule most people never think twice about: ammonia. You've probably smelled it in cleaning products. Simple, boring, everywhere, but ammonia has a superpower most people don't know about. Hydrogen, the same hydrogen we talked about earlier, is an amazing clean fuel. Burn it, and all you get is water. Nothing dirty, nothing harmful, just water vapor. It sounds too good to be true, and in one specific way, it is. The problem is that hydrogen is really hard to move around. It's the lightest thing in the universe, which means it takes up a huge amount of space unless you compress it or cool it down to extremely low temperatures. Keeping it cold and packed tightly enough to ship across oceans in large quantities is expensive and tricky. Imagine trying to mail a balloon full of air. The air inside is useful, but the balloon itself takes up way more space than the air is worth. Ammonia fixes that. You can pack hydrogen safely inside ammonia molecules, ship it across the world like any normal liquid, and then pull the hydrogen back out once it arrives. Ammonia works like a lunchbox that carries clean energy from one place to another, and once you see how central hydrogen is to this trick, you'll start to notice it's the hidden thread running through every breakthrough in this video. Normally, making ammonia takes a lot of heat, huge pressure, and tons of fossil fuel. The traditional process, called Haber-Bosch, has been around for over 100 years. It's actually one of the biggest users of natural gas on the planet, mostly because it's used to make fertilizer for crops that feed roughly half the world's population. Without it, billions of people would go hungry, so it's not something the world can just stop doing. But in Shanxi province in China, there's now a plant making ammonia a totally different way. No natural gas, no fossil fuels, no crushing pressure or extreme heat. Just nitrogen pulled straight from the air and hydrogen made from water using solar power, all at room temperature. It's already run non-stop for over 50 days straight, working better than 90% of the time. That's not a lab experiment. That's a factory floor running real shifts. This matters way beyond farming. Big cargo ships could run on ammonia instead of oil. Japan and South Korea are already testing ammonia-powered ships in the ocean right now, running real routes with real cargo. If the shipping industry, which moves about 90% of everything traded globally, shifts toward ammonia as its primary fuel, the oil that currently powers those ships becomes optional. Not cheaper. Optional. That's a word that changes everything. So now you've got clean jet fuel from air, power storage from frozen air, and clean ammonia from sunlight. 3 separate ideas. But they all lead back to one single ingredient that ties everything together, and it's time to look at that ingredient directly. The one ingredient behind everything. Every single breakthrough we just talked about needs hydrogen. The jet fuel needs it to build the fuel molecules. The frozen air storage runs on clean electricity, and hydrogen helps make that electricity. The ammonia plant needs hydrogen as its main ingredient. Hydrogen isn't just one piece of this puzzle, it's the piece that connects every other piece. This is the real engine hiding underneath everything you've seen so far, and how much of it a country can produce might matter more than how much oil it has. So the real question becomes, how much hydrogen can one country actually make, and how fast is that number growing? Back in 2019, China made about 23,000 tons of clean hydrogen a year. By 2024, that number jumped to 125,000 tons. That's almost 6 times more in just 5 years, and it's still speeding up. To put that in perspective, that kind of growth doesn't happen by accident. It happens when a country decides something is a priority and puts real resources behind it. One province alone, Guangdong, is building a giant offshore wind farm just to power machines that split water into hydrogen. That single project alone aims to make 80,000 tons of hydrogen every year. One province, one project, almost as much as the entire country was making just a few years ago. Here's something even bigger. China now makes about 65 out of every 100 machines used worldwide to split water into hydrogen. Those machines are called electrolysers. They're the key piece of hardware in this entire system, the device that turns electricity and water into hydrogen. Whoever builds that machine controls how fast this whole shift can happen, not just at home, but everywhere else buying it too. Think about what that means. If a country in South America wants to switch to clean hydrogen, they need electrolysers. If a nation in Africa wants to build a green ammonia plant, they need electrolysers. If a European airline wants synthetic jet fuel, the whole process starts with an electrolyser, and most of those machines will come from one country. The government has even made hydrogen an official part of national energy law, giving it the same importance as oil and gas. There's a real target to make it cheap enough to compete with oil within just a few years, backed by a huge chunk of direct funding. We're talking billions of yuan committed to making this happen, not as a research project but as national infrastructure. Even old oil companies are feeling the shift. One of the country's biggest oil refining companies saw its profits drop by more than a third in 2025, not because people stopped using energy, but because alternatives started competing, and their response was telling. Instead of fighting the change, they committed nearly 800 million yuan to turn one of their old fuel plants into a clean jet fuel factory. A company built on oil is now rebuilding itself around something completely different, which tells you just how real this shift has already become. But there's still one more piece to this story, one that makes everything else look small in comparison, and it's the piece that ties the whole video together. The final puzzle piece. Every technology we just talked about still depends on something outside its control. Solar needs sunlight. Wind needs, wind. Even the best storage systems are just working around the fact that energy supply isn't steady all the time. You can store it, stretch it, and save it for later, but you're still chasing something that comes and goes. So what if there was a power source that never stopped? No sunlight needed, no wind needed, just constant power day and night, no matter the weather, no matter the season, no matter where on the map you are. There's only one technology that could ever pull that off: fusion energy, the same process that powers the sun itself. Here's the basic idea. You take 2 tiny atoms and force them together at extreme heat, temperatures hotter than the center of the sun. When they combine, they release a massive burst of energy. No harmful gas released, no dangerous waste left behind, and the fuel it needs comes from hydrogen, which comes from water, and water covers most of this planet. You could run a fusion reactor for centuries using the hydrogen in a single lake. China's main fusion machine is called EAST, which stands for Experimental Advanced Superconducting Tokamak. It's basically a giant donut-shaped chamber lined with powerful magnets that hold a cloud of superheated gas in place. This year, it hit a huge milestone, holding a stable reaction longer than any attempt before it anywhere in the world. It pushed past what scientists call the Greenwald limit, which is a technical way of saying it did something that wasn't supposed to be easy to do. Now, fusion power isn't ready for everyday use yet. It's still years away from powering your home or charging your phone. Anyone who tells you otherwise is selling something. But the direction is clear, and huge amounts of money and effort are being poured into it. And once you understand what fusion could unlock, every earlier breakthrough in this video starts to look like a piece of one much larger machine. Here's why this matters so much. Every single breakthrough in this video becomes even more powerful once you pair it with an endless supply of clean electricity. Jet fuel factories could scale up without limits, turning out as much fuel as airlines could ever need. Hydrogen production could become almost unlimited, feeding into ammonia plants, fuel factories, and power grids everywhere. Frozen air storage could support entire power grids that never run low because the electricity feeding them never stops. Put it all together and you get something the world has never really had before, a complete loop. You put in air, water, and electricity. You get out fuel, chemicals, fertilizer, and stored power. Nothing dug out of the ground, nothing shipped across oceans, nothing tied to a single country's geography or a single narrow strait that someone else could block. For over 100 years, power in the world meant controlling oil or controlling the routes oil traveled through, places like the Strait of Malacca, the Persian Gulf, and old pipelines snaking through Central Asia. That geography mattered because energy had to come from somewhere specific and then travel to somewhere else. Whoever sat on top of the deposit had the leverage. Whoever controlled the shipping lane had the leverage. The map itself was power. But if you can make energy anywhere using ingredients found everywhere, then that old kind of power starts to fade. It won't be about who owns the oil field anymore. It'll be about who builds the machines that make energy from thin air. The reserves stop being leverage, the choke points stop being strategic, and the country that builds and sells those machines becomes the one with real influence. And right now, one country is building those machines faster than anyone else. It already makes 65% of the world's solar panels. It dominates electrolyser production. It's exporting the infrastructure of the new energy system the same way oil-producing nations once exported barrels. The product is different. The logic is the same. This shift isn't a prediction anymore. It's happening in real factories, in real deserts, and in real labs right now. Over 1 billion gallons of new renewable fuel capacity is already moving into production pipelines this year. Hydrogen output is multiplying. Entire refineries are being rebuilt around synthetic inputs. These aren't plans on a slide, these are construction sites with cranes and concrete. The world that ran on oil didn't announce its own ending. It just started losing ground to something faster, cleaner, and impossible to blockade. One facility at a time, one technology at a time, one country building the machines, while everyone else is still debating whether the transition is real. If this video gave you something new to think about, hit like, subscribe, and turn on notifications because the next video is going to connect even more dots you probably haven't seen yet. Here's a question for you. If energy can really be made anywhere from just air and water, which country do you think is the least ready for that kind of change? Drop your answer in the comments.